So, in the past, we have talked about asynchronicity in online. I want to continue that line. Um, and what I want to present are the latest changes that we've done in this year to make things even more asynchronous. And I want to walk you through the code and give you the opportunity to ask questions and maybe even raise concerns if there are any. I'm going to show you two features. One is locking, which by and large we've converted to asynchronous with notable two exceptions. And the other one is recovering from upload failures, which is unexpectedly involved asynchronous requests as well. And I'm going to walk you through that. And I'm going to show you um, not just how these two features work in their specific ways, but also how in general we coordinate asynchronous requests so that you're familiar with the general pattern. And I guess the one of the goals that I have in mind, other than to make sure that this knowledge is uh, familiar to most people, is to help people who might need to troubleshoot something or read logs, or maybe even a test failure or something like that, to be able to better orient themselves and understand what's going on and be mindful that things might not be straightforward at all. That's the unfortunate downside to asynchronous things, right? Because there is non-linearity. So just keep that in mind. On the plus side, we get significant performance gains simply because you don't have to block the thread that's doing everything that's important to do an HTTP request or something like that, which can have pauses and hiccups that are just unbounded and uncontrollable. Really, yeah, it can be milliseconds, or it can creep to very large numbers. Really. Okay, so let's start with the locking. Locking is, in principle, is very simple. We have a unique token that we generate. We send the WAPI like host a request saying, "Can you please, using this token, make sure that nobody else can modify the document because we're using it." And that token is how we identify the owner. So if there is a lock already, our request is going to fail, and eventually the token expires. So we need to refresh this token uh, in a certain with a certain timeout that is configurable. That's where the asynchronicity comes in, because what will happen is you're editing the document, and every so often we need to do this HTTP request telling the WAPI like host that, look, we have this token, we don't want it to expire because we're not quite done yet. And we don't want to pause the editing, right? We don't want you to notice that all of a sudden your inputs are, they're not responsive, you're not seeing the update, and so on. So what we do is we do that request asynchronously. But before I get to that, there is a related change that we did in 2404, in the latest update, actually, which is that now we only do the locking after we've successfully loaded a document rather than before loading the document. Um, I won't go into why that is, important and necessary, but the bottom line is that now when the document is fully loaded, that's when we try to lock it. And this is what you see on the screen. So when the first view is loaded, we go and do this lock if editing. And what this will do is it will check if we need to do locking at all. And if it is true, then we would issue a lock request. And this is synchronous. We do this synchronously because if you do this asynchronously, then you have much more complexity and test failures, etc. Because it is gonna race with other events. So that's a technicality, but in terms of performance, this is perfectly fine because the document hasn't even shown on the screen. It might be slightly more performant in terms of loading, but we already have parallelism left and right when we're doing the loading, so this wouldn't really make a huge difference. So this one out of the way, let's actually look at what we do when we need to refresh. When we need to refresh, we issue an async request, and this is where the fun begins. The async request, the checks notwithstanding, require a callback that's going to be the continuation. That's what we do when we are done with the request, and we issue here we issue the HTTP request to the server. The relevant parts that you need to be mindful of, which is the pattern that we use, is that we always have a request object that captures the relevant things. Specifically, it has to capture the session that issued the request because we need that session later on, right? And we need to know whether we locked or unlocked because we need to understand what failed when it fails. And conversely, when it succeeds, we also need to know what were we doing that succeeded to update the state as necessary. So you would notice that we have this object here that is controlling that's holding the state, and you can see it's a fairly small object that simply has the object and the session. And we also have a timeout to track how long it took and so on. So this is basically how we do it. When when the callback is called, we get a couple of information. I'm losing my way here. We get this async lock update instance, which basically tells us, here I want to show you, it basically tells us the status of the call itself, what happened. And you can see that there is unsupported, and this is because we also want to issue the callback when locking is unsupported. So you're trying to lock on a, uh, say, a local file, or maybe the WAPI host says, locking is not supported. So in those cases, we still want to have a homogeneous way of handling error. So we would issue the callback and we would say, this is not supported, move on. Even though we do check, in most cases, it's more consistent in terms of design when you have support for all cases and not just make assumptions that something will never happen. It just makes things easier and catches regressions cleanly. So this is the object we get, and it's fairly straightforward from here on, right? We're either still running, so we haven't finished yet, and again, you can see this is part of the design approach of being consistent, right? You want to also be able to issue the callback by saying the request has been issued and there was no early failure, say, for example, because we were out of sockets or out of memory, or there was some other error, right? And you want to be able to handle those cases cleanly. But if there is a final result, a permanent result, let's say for this request, that's going to be here, and here you can see that it's either unsupported or it is successfully finished. And in this is the case where we need to know if we were locking or unlocking so that we can log and update the state. And this is the most important part, by the way, because this lock context is how we know if we have the lock or we don't have the lock. And this is important because we need to unlock when we're done with the document, obviously. And finally, here we have the failure cases. Typically, you are either unauthorized because your access token is invalid or expired, and that we need to handle here, as you can see, by setting that the locking had failed. And we have a general failure here. This can happen when the HTTP request times out, for example. And again, we need to handle that intelligently as well. And finally, when we are done with the document, we need to unlock if it is locked. That one is slightly um, slightly more complicated. I will just introduce it to you so that you're aware of it. So you see here is one such case that we update when we are disconnected. And this again, we check if we are locked, then we need to unlock, and this is where we do it. It is again synchronous, um, because we need to make sure that we know whether we have the lock or we don't have the lock. Because after this point, if this was the last editor, we cannot edit. So we need to basically make the document read only when the last editor who had the right to modifying the document has disconnected. So this is one case, and the last case is when we unload the document. We also make sure that if we still have the lock, that we unlock it, and then we're good to go. So this is the locking, and I want to pause here and give people maybe an opportunity to ask questions if there are any. Yeah, Cosmin, please go ahead.
I'm not sure if I understood correctly. You mentioned that the WOPI server might support or not file locking. So the lock is actually something that happens on the WOPI server.
Yes, that is
Is
correct, and it is
okay.
optional. It is optional. The server might say it doesn't support locking, and I can imagine there might be cases that wouldn't be necessary. For example, if sharing is not commonly used, so it's exclusive ownership, that would be one reason. But yeah, it's up to the host. And yes, absolutely, because storage is where locking is relevant. So the storage server has to do the locking and has to own and track the locks.
Okay. Okay. And then you mentioned that we do unlocking when we're done with the document or when with the last editor or something. And I
Correct.
was wondering what happens if there's a crash and we don't get the chance to unlock at all.
The answer is that there are no crashes. We don't have crashes. That's the correct answer. No, obviously that is a an extreme case, and yeah, we really try to make sure that col.WSD as a process is extremely stable. It's the most critical component. Um, so if that happens, um, I do not know if there is a manual way of unlocking, but it will time out depending on what timeout the server has. Unfortunately, the token is lost, so there is no obvious or easy way to recover the token and do an automatic thing. Luckily, I've never heard any reports of such a thing ever happening um, so far. But yeah, the timeout is there for that reason, right? Eventually, it will time out and it will release the lock.
Okay, that sounds
which
good.
which is why we have the refreshes, right? The whole idea of the refresh is to extend the timeout, and the timeout typically is in minutes. I mean, definitely it shouldn't be in days, right? If it is an hour or something like that, which might be reasonable, so it certainly shouldn't be much longer. There's no good reason for it, right? Because you can always extend it easily while you're continuing to edit. um,
Yeah, makes sense.
right,
Okay, thank you.
Gabrielle, thank you. Gabrielle, did you have a question? You can unmute.
Yeah, sorry, I forgot. Can you hear me, right?
Yes.
Yeah, okay, thanks. So I just wanted to add to the scenarios that Cosmin mentioned. Okay, I understand. I agree with you that there should be no crash, and there is no crash. But a more realistic scenario is when the WOPI host is unreachable. Yeah, since communication with the WOPI host, WOPI server is through REST protocol. So if
Yeah.
the host is unreachable, you will and the user closes the document. Yeah, it could reproduce the same scenario as if the application crashes, right?
Yeah, that is correct. That is correct. Um, those cases are tricky in general, simply because it's availability issue, and obviously, if this is common, then that would be a problem in general, and it's a hard problem to deal with. Um, but as long as the document is open, it's fine. We won't reach it. The async refresh is going to time out. We're going to log that it timed out, and we fail to um, update the lock. But editing will continue, right? And because it is async, even if we're timing out, we're not really pausing editing for the duration of the timeout, which, I mean, it's typically in the tens of seconds, right? So everything will work very smoothly from the user's perspective. I'm not sure if we notify of such a failure. I think we don't, because it's not a user visible thing. Unlike saving and uploading, that we do notify, and we do have a message on the UI. But as long as the document is open, everything will work fine. And eventually, when the service is back, hopefully before we close the document, everything will be fine. If you get unlucky and you've closed the document and it's unreachable, that's an edge case, right? Yeah, in that case, you're right. We're gonna try, and in fact, we're going to try twice. Um, Once when we get the disconnection, and again, right before basically cleaning up the internal structures for that document. So there are two opportunities for doing this, and it is synchronous. So we will pause, we will wait until it times out, and then we're going to try a second time. Um, but there's so much you can do if you try to hold on unloaded documents because you're trying to reach the server to unlock, you're eventually going to destabilize the server potentially if you have too many open documents that you can't unload. You see what I mean? So at some
Yeah.
point, you have to be reasonable and say, okay, I mean, clearly there's a problem with the host. I'm not going to destabilize my whole server because of that. So we have to just give up, and that's what we
Mhm.
do.
But
If that makes
but
sense.
the WAPI protocol does not provide a mechanism to unlock the file after that. I mean, through okay,
I mean, technically, it doesn't know that we've unloaded. It has no idea.
yes, yes,
So
I agree.
technically, you should be able to send the same. I mean, if you can form the correct HTTP request and send it with the correct token, yes, you can unlock like that. But again, the problem is there is no easy way to recover the token unless you have like some sort of a persistent file or database, and then you retry them. That's much more complexity than it would be necessary in most cases, because most production systems have high availability. So it's not like we assume that the storage server is an unreliable host, because if that were the case, then I think users would be worried about their data before us being worried about failing to unlock.
Hmm.
If you see what I mean.
Yeah.
So the storage has to be. I mean, when it doesn't happen often, but I can remember a couple of cases where we have noticed that the storage was unreliable. And we have notified the partner that they really have to make sure that the storage is reliable, because then you get version issues, and you get real problems, and then the users try to restore manually because they think they got the wrong version, and the whole system becomes unreliable and problematic. But luckily, that is quite rare.
Hmm. Okay. Yeah, I understood. So is the this is the issue for let's say the WAPI server admin to handle those, let's say, locked files, right?
Correct. I mean, again,
Hmm.
it will eventually time out and it will unlock. So the server,
Hmm.
the server has that doesn't keep the lock indefinitely, and that's
Hmm.
by design. Specifically, this is because it's REST API. I mean, they know that but also because you don't have sessions and tokens that are indefinite anyway. So again, it doesn't make sense to have locks that are explicit and forever until they're unlocked. So yeah, depending on what I would recommend is A, make sure that your server is stable and reliable. Same for connections. B, put the timeout to a reasonable value, such that if you think that you're unreachable every so often, that within a few minutes it would unlock and everything will be fine. Final thing, keep in mind the lock is only for editing. Your document is still there. You can view it. You can download it. It's reachable, as provided you have the right permissions and access to it. So it's only editing that you wouldn't be able to do if it is locked, and you can't unlock it sooner. So that's the only loss of functionality. And again, this is a very very extreme edge case that has to do with the infrastructure,
Mhm.
not a bug necessarily.
Mhm. Okay, thanks.
Thank you for the questions. All right, in the interest of time, I'm gonna move to the second topic, which is handling failures to upload. So let me first introduce the scenario, because it's tricky and it might not be obvious. Um, when we upload the document, we only have the document and we only have the timestamp of the version that we downloaded. The timestamp is important because that is how the server can help us detect if the document was modified in the storage. So imagine you're editing your document and somebody else who has right permission to it uploads a different version. Say they had a local modification, or they were working offline and now they came online and they upload it. So now what happened is you have two versions. Your changes that are happening on Collabora Online will now be out of sync with the version that is in storage. If you try to upload because you're saving your latest edits, the timestamp that we send to the server, to the WAPI host, is going to be different from the last modification timestamp, which is going to be your colleague's upload timestamp. In that case, you will get back, um, uh, I believe it's you'll get back 403, um, which basically says that there is a conflict. Actually, I don't think it's 403. It might be a different code. At any rate, you'll get back a code that says there is a conflict. This is no good. You can't upload this. This is the normal scenario. What we do in this case, we show the user a pop-up and say, "What do you want to do?" There is a different version. You have a choice. You can either ignore your changes and keep whatever is in storage as the latest one. And if you do that, we will reload the document from storage and show you what was in the storage at that point. And that's one scenario. The other one is you can overwrite the changes in storage with your version by saying, um, no, basically overwrite it. I'm not interested in what's in the storage. My changes are more important. And in that case, we will upload and tell the server we want to force this version over the existing one. And that's a different scenario. And in that case, you continue editing as if nothing happened. Now, keep this in mind. And now imagine you're editing your document. There is no colleague who's trying to upload anything. It can even be only you editing the document. In this scenario, when you save, we upload, and you shouldn't expect any issues, except if if the server is slow or there's a network issue and we time out, we do not get back from the server any response. Now, keep in mind that normally we need the timestamp of the last version that we had synced with in storage, right? That was the one key to detecting conflicts. Now we don't have that, and there are two outcomes. We timed out, we don't know what happened on the server. One possible scenario is that the server did not store the new version. Basically, internally, there was some sort of an error, say the database was slow, or there was a lock on the database, and the lock timed out and eventually gave up. There are all sorts of scenarios. We don't have to worry about them. Just conceptually, it failed. It failed, so there is no change on the server, right? And the next time we try to upload, it will work fine, and everything is great. But more often than not, what really happens is that the server is slow, but eventually it succeeds. So the connection timed out, or maybe the network interrupted the connection, right? But the version that we uploaded succeeds in getting ingested into the database and in the storage, except we don't know about that, right? So that's the second scenario. Um, and in that case, we really need the timestamp because if we don't have the timestamp, we can't upload. Rather, when we upload every time, we're going to get a conflict because this scenario is indistinguishable from somebody else uploaded, and we don't know about that, right? If you think about it, there is no way for us or the server to know that the version that's in the storage is the same one that we have, that we've been editing. So we need a smart way of recovering, and that's what we do in this case. And I'm going to show you how we do that. Um, this is very new, by the way, and it's going to be released in the next version. So I'm giving you like bleeding edge changes here. So what we do when we get a failure to upload, which is this scenario, we start a sync file timestamp activity. So we mark internally that we're going to sync, and what we do in this scenario is that we get the metadata of the document again. So the check file info is how we do that. And this is what we're doing here. We issue a check file info request, and this is going to give us the details of the file. Now, this is technically, this should be 100% sufficient for us to recover everything we need. Unfortunately, um, most storage servers do not provide a checksum of the file. Had we had a checksum, we can compare with the file that we have opened and editing, and we would be 100% certain if it is ours or it isn't ours. Okay, so that doesn't happen, and this is the comment here that you see. We really don't have the checksum in most cases. So we haven't implemented even support for it because again I haven't seen a single one that provides this checksum. Maybe there are some servers out there that I don't know about, but at any rate, what we do is something different. We try to check the size because it is highly unlikely that there is any material edits that will give you the exactly same size. And if the size is different, then you know for a fact that this is a different version of the document and there is a conflict. And basically, you just declare that I have a conflict. Okay. But if the size is the same, in that case, um, uh, we assume that everything is likely to be okay. We don't know for sure. That's the assumption. Okay, and we synchronize with the timestamp and we move on. So this is the approach that we have right now. There is one scenario where we fail completely, and in that case, we assume there is a conflict and we fall back to the current behavior. And that's it. So this is an improvement in the sense that we will have at least some of the cases reliably detected as being a conflict. And in the cases that we think there is probably no conflict, we will just recover the timestamp and resume as if nothing happened. In the future, we do have plans to implement the checksum, so that where it is provided, it will be 100% secure in telling us that there is a different version of the document, or it's the same version as the one that we uploaded, and that will be foolproof basically. But for now, this is what we do. So how we do this is fairly straightforward. As you see, what I'm showing you is the callback for the check file info. And again, exactly like the async locking, we issue a check file info asynchronously, and we carry on editing until we get the callback, and the callback basically tells us what it is that the result is, and that's how we know what to do next. And that's it. That sums up basically the recovery as well. Any questions?
Okay, thank you, Ashod. Questions, guys. Cosmin, do you have more questions?
No more questions. Thank you.
Okay, Gabriel?
No, me neither. Thanks.
Thank you. Miklos, questions, tips?
I would have a question. When you do all these async activities, I assume that like conceptually what you create as a job, you put that on that socket pole of the current thread, and that gets the callback executed once we have some HTTP answer for the
Yes.
HTTP request, right?
That is correct, yes.
So what the other day I was reading that code, and what was a bit confusing to me as, or like what was a bit unclear, is that we keep talking about polling there, but polling seems to be used for two purposes. Polling in the sense that we check if there is some information on that socket, so now we can read from it and it won't block and things like this. And at the same time, polling is check if there is something to be done and do it type of activity. And since these two things are separate, at the same time we refer to both as polling. Is that clear, or am I just completely confused? Or
No, I think you're right. And I'm well aware of this. I have let me share my thoughts on this. So the original design, which goes back many years now, is that everything is organized around the socket activity, and that's how we approached it. So the socket activity is how we trigger these um, um, wakes basically from the poll. So you are absolutely right in that there are two scenarios. One is the obvious one. You get some activity on the socket, and typically that's some data coming in. And because we always wait for a read, that's going to wake us. But the other one, we don't do it as well as we should. And I've always wanted to change the way we did it, but it's a big change. Maybe not too drastic, but it will require touching a lot of code. And that is um, for activities that we need to check on that has nothing to do with the socket. Best example is timeouts, right? If you want to check for a timeout, you want a timer, but you already have the poll, right? And the poll has a wake on a timeout. So what you really want to do is you want to reverse the order of things, in that every time that you are awake and checking for things to do, you have to come back with the next time to wake up. So unfortunately, we don't do it that way. And again, I don't want to go into details how we organize timeouts. It's not too complicated, but instead of saying when do you need the next check to happen, which basically is the minimum time, we ask this much time has elapsed. Can you check if there is a timeout, which is the opposite way of doing it, right? We shouldn't do that. I think we should instead solicit the amount of time that we can go and do other things before we come back and check on you. And every piece of logic that needs to be notified or called to do some activity will tell us how much time they have before the next checkpoint. So they would say, for example, I have 5 seconds, or I have 200 milliseconds, or 30 seconds. And what we would do, we would take the minimum of that, and that's what we would give the poll. And we would tell the poll, wake us up if you get any of these socket events with the maximum timeout, and we will give that minimum time to the next checkpoint. And that might be 1 second, might be 200 milliseconds, as I said, or something completely different, the maximum timeout if there is no activity in the near future, right? And that way, you can do both things in a consistent way. But the reason that you've noticed what you noticed, in my opinion, because that's how I model it as well, so we have exactly the same mental model as I understand, is that we don't do it like that. We just do the sockets polling, and we give it typically the maximum timeout, which is always the same, typically, because we do have a couple of edge cases where we give it a different timeout, without any regard to activities that we need to do with certain frequency or at a certain time. So I don't know if it answers your question, but at least it confirms that your what you noticed is valid, I think.
Yeah, it does help. Thanks.
Thank you. And I would like to change it. I would like to have the timeouts to really be deadline based rather than you know, can you check if you have something that timed out at some arbitrary point, which is not very reliable.
Okay.
Back to you, Anna.
Thank you, Ash. Thank you, Miklos. Noel, questions?
Not from me.
Attila?
No questions, thank you.
Bayram? No questions. Kellen? Questions?
Just about async callbacks, both in online and core. When you just have one or two things, they're relatively straightforward to manage. But when the chain gets longer and longer, it gets more and more complicated. And while it's a different type of scenario, like the C++ latest whatever versions have like standard async and standard futures and all the rest. And I just wonder, has there been any kind of thought about structuring these async callbacks in some kind of a way to indicate which is the final step that matters, and kind of use something along those lines, that instead of using threads, just uses our kind of whole as the kind of synchronization point for these things.
Apparently, I need to unmute to speak. Okay, good question, Kalen. So there are a couple of things on that. One is that the very first design of online used explicit threads, and even though I don't remember having a thread pool, we did fire up threads for all sorts of various things, right? Now that had two problems. One is it doesn't really scale very well, and the second one was just the complexity of managing all the locks and all the potential deadlocks. And it became very clear at some point that we are spinning our wheels trying to fight a losing battle. And Michael came up with the design really of the socket pool that we have now. So that's designed specifically with the um, with the design architecture that you have a document model that's by and large single threaded, right? So any multi-threading that you're doing is going to be overheads. That's going to be a performance issue, even if you have figured out how to do the locking in a very sane way, which again, it doesn't scale, and you have all sorts of problems, even if everything works fine. Out of order events is a very easy example. So we stayed away from that, and instead what we do is we try to stick with one thread per document, which is the doc broker poll. And that's what we use for all of this. Now, the second point is that really makes it tricky, and the code is fairly complex when you're trying to do these asynchronous socket activity with certain continuations that you need to do as a second thing after that. And we have a couple of cases like that. Unfortunately, it's fairly complicated. I have to agree with you. But the thing is that we should be able to change the interface such that it would behave in a similar way that say Stud Future does. And indeed, I think we approximate that with the request objects that we have that are simply um, um, unique putters, and we have callbacks, and in the callback technically you can do any you can issue any new request and have a chain of continuations. But I agree, it can be simplified and it can be done in a less error prone way. There are a few sharp edges, not too many, because it's not it has been polished fairly well. So to contrast that with the idea of having I don't know, something like package task, or a future and a promise, and that kind of a model, is to risk um, you know relying on a thread pool, or or maybe even on-demand thread spinning up, or something that would be a nightmare for all the reasons that I gave already: performance, debugging, etc. So the potential solution that is in between these two extremes might be something like coroutines, right? Because again, we have the thread; it's a socket poll, but to Miklos's point, when you're not really doing an activity that is strictly socket bound, but you still need some sort of an activity that needs to happen at a certain point in time, like a timer event or something like that, then you can organize that without registering sockets, without really worrying about the socket pool. All you need is some kind of a way to switch the context and call that activity handler, right? And do that with some frequency, which again, the poll, if done correctly, can give you a very reliable callback to do these things, right? So a coroutine might be a sensible solution that doesn't, require a lot of resources, and it's fairly clean in terms of the interface. So that's one possible answer. The other one is, let's improve the interface that we have now, and maybe adopt something that's more akin to what the standard does, except we don't spin a thread. We just do it on the socket pool that we already have. So these are my thoughts, at least. I don't know if it was helpful or not.
Yeah, no, that's just what I was thinking. So I've no actual interest in using threads to solve the problem, but just using that style of interface kind of backed up by going through the socket poll for each step of it, but where that you could actually specify in a fairly linear fashion, in one area what you're trying to achieve. There's 5 steps, if this, if that, the other, and as each step is completed, the next one runs. And it all goes through the socket poll fine, but just have some kind of a syntax so it isn't manually done everywhere and you have to trace through, the 10 or 11 files or 10 or 11 actual standard function implementations of launch the next step and then try and track it around the place. No, just syntactically,
Yeah.
it's interesting to have it more like what we said earlier. So your third option there sounds like a wonderful idea.
Yeah, absolutely agreed. Yeah, so it's between coming up with our own interface, or adopt something like coroutines, which should basically do that. You'd have a chain of continuations, and it would be done, and it would get called, with some progression, right? Whenever you have the time slice, you would call it, and then you would yield to do other things, and so on. Yeah, that's definitely, it can be done.
Okay, that's it.
Thank you,
Thank you.
Ash. Thank you, Kellen. Next is Darshan. Questions, Darshan. Okay. No questions. Okay. Gukai, no questions. Jaume? No questions. Joao? No questions. Mevan? No questions. Justin? No questions. Okay. Berg? Hopefully I pronounced it. Okay. Timur? I guess no questions. And Thorsten doesn't have questions. Thank you everyone for joining. Okay, thank you.
Thank you.
See you next week, guys.
And hi, Stefan and Thorsten. Sorry, Anna.
No problem.